This video series is based on the semiconductor physics, the basic idea of the semiconductor material, and how the basic atomic structure help to develop the energy bands in solids, and then after the basic concept of p-type semiconductor and n-type semiconductor. So these are the 4 points of discussion into this particular video. Right. So first of all, I am discussing about the classification of solids. As you know that solids are categorized into the two category. Number 1 metal and number 2 insulator. Sometimes some people can consider semiconductor as a third category of the solids, but in general we know that semiconductor lies into the insulator category of the solids. Right. So classification of solids. Number 1 metals, considered to have permanent electron gas. In metals, basically what happens that outermost electron, that is known as valence electron, is almost free from the Coulomb forces, and because of that electron can move here and there. So if there are large number of atoms, so all the free electrons are treated as free electron gas. So this gas can be influenced and moved by magnetic and electric field. So all these electrons can be affected by the magnetic field and electric field. Number 2, what are insulator? How these insulator are different from the metals? So virtually no free electrons. So there is no electrical conductivity into the insulator. So what are the possible examples of the metals and insulator? For metals, gold, aluminium, copper, all these are metals and are good conductor. Insulator like wood, so wood, plastic, paper, all these things basically are an example of the insulator. And the third point is related to the semiconductor, which lies basically in between these two classification of the solids, insulator and metals. So in the pure state they are perfect insulator at zero absolute temperature. So this is the important point about the semiconductor materials, or you can say solids. Now the second part of this is related to the analysis of aluminum and silicon, because this series is based on the semiconductor physics. So I have to basically explain everything related to the semiconductor physics. So now the analysis of aluminum and silicon. What are the similarities and what are the differences between the aluminum and silicon? So as you know that aluminum has atomic number 13 and silicon have 14. So in the periodic table, what is the atomic density of aluminum? That is about 6 into 10 raised power 28 atoms per cubic meter, and almost same for the silicon, that is 5 into 10 raised power 28 atoms per cubic meter. And now about the density of aluminum, that is 2700 kilogram per cubic meter, and here for the silicon, that is 2300 kilogram per cubic meter. This is almost same, so equivalent to the aluminum, right, the mass density of the silicon. And similarly you can see here that binding energy of an electron in aluminum is equivalent to the binding energy of an electron in the silicon metal. So these are basic properties of any metals, and here the comparison of aluminum and silicon, all these properties are same for both the metals. And now about the melting points. For the aluminum this is 660 degrees C, and for the silicon this is 1414 degrees C. It is almost 2 times than the aluminum. So melting point is very high for the silicon, right? And now the other thing, except to the electrical resistivity, the other microscopic properties of aluminum and silicon appear to same. So these are the microscopic properties of the aluminum and silicon, and these are almost same except to the electrical resistivity, right? And here you have seen that through the temperature, that there is large difference between the temperature. So this was the basic introduction of the aluminum and silicon. And silicon is the semiconductor material, aluminum is metal. And now the second step, now we will discuss about the basic concept of the atomic structure that is related to the quantum numbers. As you know that there are 4 quantum numbers. With the help of that someone can categorize a particular electron, right? What are the significance of the quantum numbers? With the help of quantum numbers one can categorize, classified an electron inside the atom. So you know that all the electrons are almost are identical particles. So how they basically are differ from one to this other? So they are differ with the help of quantum numbers, right? So this is the idea of quantum number. This is the concept basically of the quantum numbers. So many times you have listened about the Pauli exclusion principle and other related principles. So all these basically are based on the quantum numbers, and you can understand that depth if you know about the importance of these quantum numbers. So I am discussing all these quantum numbers systematically, right? So these are basically 4 quantum numbers in an atom. Number 1 is known as principal quantum number n, that is represented by the small letter n. So n is equal to 1, 2, 3, 4. This number signifies the name of the cell. So if n is equal to 1, it means that is the K cell. If n is equal to 2, that means L cell. N is equal to 3 means capital M cell, and similarly for a small n is equal to 4, that is represented by the capital N cell. Cell is these particular energy levels basically. This is center at the nucleus plus Ze, and 1, 2, 3 these numbers signifies the name of the cells, right? K cell, L cell, M cell and N cell. So this is the idea of quantum numbers. First quantum number, that is the principal quantum number. And now about the second quantum number, that is the orbital quantum number. It is represented by the small letter L. So how to find out the value of orbital quantum number? That is basically defined with the help of principal quantum number. If you know the principal quantum number, you can find out the orbital quantum number. How? So that is basically defined through this one. For a given value of n, L varies from 0 to n minus 1. It means L values basically varies from 0 to n minus 1. If suppose these are some example is taken here to define the L, that is the orbital quantum number. In the first column n is equal to 1, L will be equal to 0, right? Here n is equal to 2, so L varies from 0 to 1. N is equal to 2, so this is 0 and 1. So L is equal to 0, 1. N is equal to 3 means L is equal to 0, 1 and 2. And similarly for small n is equal to 4, L will be equal to 0, 1, 2 and 3. And this is small n is equal to for represent to the capital N cell. So for this particular cell, so orbital quantum number will be 0, 1, 2, 3. And now the second question, what it signifies? If suppose you find out this numerical value 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, what basically it signifies? It signifies the name of a particular orbit, that is known as orbital, right? So orbital, s orbital, s and p orbital, L is equal to 0 represent to the s orbital, L is equal to 1 represent the p orbital, and similarly L is equal to 2 represent the d orbital, L is equal to 3 f orbital. So like this, you know that there are 4 orbitals. L is equal to 0 s orbital, 1 p, 2 d, 3 f respectively. So now with the help of orbital quantum number, you are basically specifying some orbitals with the name of s, p, d, f. And now the next question, what it signifies? If suppose you have nominate a particular orbital with the name of s, p, d, f, what it basically signifies? In a very simple language, here I can say that these are the houses in a particular block. So in s orbital, how many electron basically exist? कितने इलेक्ट्रॉन exist करते हैं in s orbital? This information comes out from the s orbital. So in s orbital only 2 electron can exist. In p orbital only 6 electron. In d orbital only 10 electrons. In f orbital 14 electrons. So you can see here that in s orbital, p orbital, d and f orbital. So how many number of electrons can exist into the d orbital? That is given by the number of 10. So 10 electrons can exist into the d orbital, and into the f orbital 14 electrons. So as you know that in which orbital, in which cell basically this orbital will come, d orbital or f orbital. So if I talk about the d orbital only, that in which cell d orbital comes, so you know that is the 3, n is equal to 3 means m cell. So in the third cell there will be s, p and d orbitals. So total number of the electrons in a particular cell is defined by the orbital quantum number, and that signifies the orbitals, right? Orbitals are represented by the s, p, d and f, right? And now you have seen that how many number of the electrons lie in a particular orbital. So you have seen here 2, 6, 10 and 14. So if you talk about that n is equal to 4 cell, that is m cell, how many number of the electrons will be in that particular cell? This is the 4th cell, right? That is represented by the n. So how many number of the electrons will be in this particular cell? So you have to count all the electrons in every orbitals. So there are 4 orbital s, p, d and f. How many number of electrons will be total? 2 in s, 6 in p, 10 in d, 14 in f. Sum of these electrons will be 2 plus 6, 8 plus 10, 18 plus 14, that is 32. So total number of electrons in the 4th cell will be 32. And similarly for n is equal to 3, you can find out the total number of electrons, or total number of electrons in s orbital, p, d orbital, they are 18. In second cell n is equal to 2, the total number of electrons are 8, and n is equal to 1, there are only 2 electrons in s orbital. So by this way you can find out the total number of electrons in a cell and in an orbital also, right, with the help of this orbital quantum number. Now the third quantum number, that is known as the magnetic quantum number. So for a given value of L, if you know the value of L, you can basically define the ml. ml values vary from minus L to plus L for a given value of L, right? So here you have seen in n is equal to 1 cell, there is only L is equal to 0. It means there is only one orbital, that is s orbital, right? So for n is equal to 1, ml value will be vary from minus L to plus L, but here L is 0, so ml basically vary from minus 0 to plus 0, that means only 0. So L is equal to 0, ml is equal to 0. But in case of n is equal to 2 cell, there are two values of L, one is 0 and second is 1. 1 represents the p orbital. So in case of p orbital, the ml values will minus 1 to plus 1. So this is L is equal to 1, and because of that L is equal to 1 value, ml will have minus 1, 0, plus 1. In case of L is equal to 2, right, ml, how many value of the ml will be? These will 5. So ml will be minus 2, minus 1, 0, plus 1, plus 2. So this is the magnetic quantum number. If you know about the L, you can find out the value of ml, right? So this was the third quantum number, and now the fourth quantum number is the spin quantum number. Spin quantum number is associated with the rotation of electron, rotation upward or downward. For upward rotation of the spin is represented by plus 1 by 2, and for the lower rotation, downward rotation, that is represented by minus 1 by 2. So ms is the spin quantum number. So these were the four quantum numbers which are basically helpful to describe the energy band. So here I have discussed about the basics of the quantum number. Now into the next slide I will discuss about the same quantum numbers, that how identical particles are can be distinguishable. As you know that if I consider a case of neon atom in which how many number of the electrons? 10. So how these 10 electrons are distributed into the cells and orbitals, and as you know that each electrons have the same mass number, right? So how one can make distinguishness among the 10 electrons, that this electron is of this particular orbit or this particular electron is of that particular orbital, right? So in the next slide I will discuss about it. So this was the first part, that was the basic. Thanks for watching this video. If you have any doubt or any question, you can ask me that through the message below of this video.